So when people talk about green hydrogen, typically they mean hydrogen created from renewable electricity. So usually solar or wind power used to split water into hydrogen and oxygen. And that green hydrogen results from that. There are other colours of hydrogen. Historically, hydrogen has been made from fossil fuels, and that's referred to as grey hydrogen. We also hear a lot about blue hydrogen, which is hydrogen made from fossil fuels combined with carbon capture and storage. Green hydrogen is considered the best long-term way to produce hydrogen because it has very, very little carbon emissions associated with it. So green hydrogen has several benefits. The big two are, firstly, it's a way to decarbonise hard-to-abate industries. So in particular, thinking about the steel industry, the production of steel is quite complex, and green hydrogen is one of the few ways that you can decarbonise steel production. It can also be used to decarbonise existing uses of fossil fuel produced hydrogen, so mainly in fertiliser production and also in refining. The other big use of hydrogen, or benefit of it, is one to the energy system. Hydrogen can be used for long-term storage. So if you want to store energy, typically you can use batteries for up to 4 hours, and some countries you can use hydropower, but not everywhere has hydropower. So when the sun doesn't shine or the wind doesn't blow, and you want to have stored renewable electricity, you can do that using hydrogen. You can store it for a few days, or you could store it for across the seasons if you have large storage facilities. There are many other potential benefits of hydrogen that you read about. There's often a little bit too much hype about it, but hydrogen can be used to replace diesel, for instance, in road transport, or it can be used to replace natural gas in heating of buildings or in some industries. But there's other ways to decarbonise those. Yeah, you can use batteries instead of hydrogen in cars and in trucks and buses. You can use electrification to decarbonise industries. But there will be a few other places where hydrogen can be helpful. But the main ones are those hard-to-abate sectors that I mentioned: steel, refining, and ammonia production. The two main risks are, firstly, it's expensive. Today it's expensive to produce because the electrolysers, that's the widget that splits the water into hydrogen and oxygen, they're fairly new, and so today they're expensive. With scale and with experience, the cost of those will come down. But you also have to think about the whole value chain. It's not just the production of hydrogen. You have to store it, you have to distribute it, and then using it, the end-use applications all have different technologies associated with it. And today, they're all fairly new, so they're all expensive. And then related to that, there's some technology risk. So the electrolysers are fairly new. Quite a lot of them don't last long enough. They have to have more experience with using them to make them more efficient, increase their lifetime. And some of the end-use applications are also new. So if in transport, you need fuel cells to convert the hydrogen back into power. In industry, you need hydrogen boilers to convert the hydrogen into energy. Those are all new, so there's risks around the new technologies, and there's risks around that they're expensive. For developers, that means there's also demand risk. If you're creating a project to create lots of hydrogen, you're not quite sure how much you're going to be able to sell, and will your customers use it continuously in the amounts that they thought. There are several things that governments and organisations can do. Firstly, governments need to support this new green hydrogen industry. It needs financial support in particular, so this could be structured in a number of ways, from carbon pricing to disadvantage grey hydrogen or entities that have not been decarbonised. But financial support in the same way that historically governments supported the solar industry and the wind industry where it was too expensive. Green hydrogen is more complex and needs more support because it's not just about the production. It's also the support in distribution, in storage, and these new end-use applications that are all need support while the technologies are new and while they're expensive. In the long term, the economics will all work out in the way they have done with solar and wind. But support is needed to get this nascent industry off the ground and reduce the risks for the suppliers and the consumers of green hydrogen. At the corporate level, because this value chain is so complex and you've got companies involved in the production, the storage, the distribution and the end use, you need consortiums to form to make this work. So companies have to find partners that can fill in the parts of the value chain where they don't have expertise. So there's a lot that governments can do to help with finance in the early days, but also companies need to get together and work as consortium to enable the market to flourish. There are some entrepreneurial companies that are getting on and doing things today. Cities put in place hydrogen buses, where the electric buses, the battery electric buses, can't cope with the distances they have to drive, or you can't get the grid connection, and cities are worried about their pollution. So again, they're getting on and doing things, and there's roles for entrepreneurs to stitch together that complex value chain. Someone has to help the bus operator source the hydrogen, the refueling of the buses, making sure that all of this is going to work day in, day out across the year. So there's some interesting entrepreneurs developing businesses, helping distilleries, helping breweries, helping cities with buses that isn't reliant on huge companies waiting for massive public sector support. Elsewhere in the value chain, you've got some interesting innovators, again, small businesses looking at how can we make better electrolyzers? Or how can we find creative ways to store hydrogen that doesn't rely on massive underground storage caverns? So there's various entrepreneurs also getting involved in the green hydrogen market, not just the big companies you read about in the mainstream media. Green hydrogen is critically important to abate the emissions from the hard to decarbonise industries, especially steel industry, where it provides power, but it's also used, this is quite complex, but it's used as a reducing agent. Historically, people used coking coal as a reducing agent. Hydrogen replaces that. It's used as power or an input into the refining industry. It's used as an input into the fertiliser industry. The only way around that is to use green hydrogen. So it's critical for helping us to meet the 1.5 degrees C target.